In this video we are going to see about block diagram and block diagram reduction rules. Before going into the block diagram reduction rules, we have to know why we need a block diagram. So block diagram is just a pictorial representation of a control system. Whenever we are given a control system and an equation will be given, the equation will be of differential equations. So we are supposed to solve the differential equations and we should find a simplified control system. But solving a differential equations and getting a simplified equation is much difficult. So what we try to do here is we will try to convert the differential equations into an algebraic equations by using Laplace. So we are taking Laplace transform and we are converting the differential equations into algebraic equation. Now what we do is by using this algebraic equation, we are going to create a block diagram by using this algebraic equations, and by using those block diagram we can easily reduce the size of the control system and find a simplified control system. So before going into this reduction rules, we have to know what is block diagram, what are the basic elements of block diagram. As we discussed earlier, block diagram is a pictorial representation of all the functions and components that is present in a control system. So in the block diagram is separated into three different elements. One is block, second one is branch point, and third one is summing point. So the block is the representation of the transfer function where the input is given to the transfer function, and based on the property of the transfer function we may get an output. So this box represents the transfer function here. So then what is the use of a branch point? Branch point is to separate the input into two different inlets. So if you want to give a same input to two different transfer functions, we will use branch point and separate the input, and we will give it to two different blocks. Summing point is used to combine two different inputs, and it is being given to a transfer function. Based on the diagram given here, input 1 and input 2 are given, and input 1 is passed on to the transfer function and it is being given to the summing point, and the input 2 is directly given to the summing point. Both the things are either added or subtracted according to the sign that is given as the summing point, and the output will be obtained. So this is the basics of a block diagram. So by knowing the block diagram, the basic elements of block diagram, we can move on to the block diagram reduction rules. So we have set of rules by using which we can reduce the complex block diagram of the control system into simplified. A basic thing when you compare a block diagram of a control system and to find a simplified one is, the first rule is to find whether the blocks are present in series or parallel. So first thing we will find whether the blocks are present in either in series fashion or in parallel fashion. If it is not present, then only we will move on to other rules where either moving a summing point or moving a branch point can create a series or parallel blocks. So this is the major objective. We are supposed to find a series block or parallel block. If there is no series or parallel blocks, we are supposed to create one by using the other rules, which is rule number 3, 4, 5, 6. So we will first see the rule number 1. Rule number 1 is combining the blocks in cascade. Here we have an input A. This input A is given to a transfer function G1. The output of this transfer function is AG1. This AG1 is given to the transfer function G2. The output is going to be AG1 G2. Now we can consolidate this and we can write a common diagram which is going to be G1 into G2. So the output is similar, AG1 G2. So when you find transfer functions in series, that is that doesn't have any summing point or branch point in between, then these two blocks can be combined and written like this. So there is a multiplication of transfer function. This can be done when the blocks are in series. When we move on to the second rule, rule number 2, combining parallel blocks. As you see in the diagram, we have a input A. Input A has been separated into two different things, and it has been given to G1 and G2. The output of first transfer function is AG1, the second transfer function is AG2. It has been given to the summing point. this summing point, both the signs are positive, so this is going to be getting added. So the output has been simplified by taking the a as a common, so it is a into g1 plus g2. Now what I do is I am just combining these two blocks g1 and g2 as a single block by adding g1 and g2. This gives the same output as previous one. So if you have a blocks in parallel like this, this can be replaced like this one. So these two rules are the basic, and we are supposed to find everything with respect to series and parallel only. So if you do not have a series and parallel, we are supposed to convert it to series and parallel. So to find a series and parallel, we move on to rule number 3. Now we will consider we do not find any series or parallel component. So we are in a position to move a branch point to the right of the block. What happens when a branch point is moved to the right of the block, that is ahead of the block? So rule 3, moving the branch point ahead of the block, we are considering a block structure here. Input a is given, a branch point is being given here, and a transfer function g is given. The output of this first output is ag, second output is a. Now I am supposed to move this branch point ahead of the block. So I will draw the diagram here. The input a is given, we have a transfer function g here. So the branch point has been moved to ahead of this block. Now after transforming the branch point ahead of the block, we are supposed to get the same output. Only that means only then the outputs are same. So we are supposed to give a compensation to consolidate the output. So rule number 3, moving the branch point ahead of the block. Rule number 3, moving the branch point ahead of the block. We have block diagram structure has been given. In this we have a input a and a block diagram g, and we have a branch point here. Now we are supposed to move this branch point ahead of this block g. So I have drawn this structure again. We have moved the branch point ahead of the block, but we are supposed to get the same output. Here the output is ag and a. Here also we should get the same output ag and a. Then only this transformation or this movement of branch point from left to right is justifiable. So to justify it, we have to give some compensation. So consider a is given, the transfer function g is being multiplied, we will get a ag here. This ag will be transferred here also. So both the output is going to be ag, but according to the diagram present on the left, it should be a. But we got an output ag. So what I am going to do is I am going to multiply this output by 1 by g, such that I am getting the actual output. So what that means is, if you are moving a branch point ahead of the block, we are supposed to give a compensation that is the inverse of the transfer function. Okay, here the transfer function is g, so we are giving 1 by g. This is rule number 3. Now we will see rule number 4. Rule number 4 is the exact opposite of it. Here we are moving the branch point before the block. So consider the block diagram structure here. Here input a is given, we have a branch, we have a transfer function g, and a branch point being given. So the output, both the output is going to be ag. Now they are asking us to move this branch point before the block. So I am drawing the diagram again here. So we will have a transfer function here. The branch point has been moved ahead of this block. So we have an a input a here, and this is transfer function g, and the output of the first output is going to be ag, because there is no variation in the branch point in the first line. But in the second line we have a variation, because the branch point has been moved before the transfer function. So the input a will be directly redirected into this line, and the output will be a. But when you see the previous diagram, it is ag. So when you are going to move the branch point before the block, we are supposed to give a compensation such that this output is obtained here. So what is the output, what is the compensation we can give? The same transfer function, that is multiplication of the transfer function is given as the compensation. So here the compensation is g. So when you compare rule number 3 and rule number 4, you can find that In rule number 3 we have multiplied it by 1 by g, and in rule number 4 we have multiplied by g. So when you remember rule 3, we can easily get to rule 4, because in rule 3 it's 1 by g, in rule 4 it's g. Now we'll move on to rule number 5. It's moving the summing point ahead of the block. Here we have seen the moving the branch point ahead and before the block. Now we are switching on to summing point. Here we are going to move the summing point ahead of the block. So we have two inputs are given to the summing point, and after the summing of both the inputs, it is being given to the transfer function g, and we are getting the final output. Now they are asking us to move this summing point ahead of the block. So the block has been given here g, and you will get the summing point here, and the output is obtained here. So the second input is being given ahead of this block g. Okay, so we have input plus and plus here based on the sign there. So the output of this one is ag, and this one is b. Right? We are supposed to get the output of a plus b into g, that is ag plus bg, but we are getting ag plus b. So what is the compensation we are supposed to give? We are supposed to give a g here. So we will just multiply it by g. So the output is ag plus bg. Now what we can understand is, when we are going to move a summing point ahead of the block, we are supposed to give a compensation, that is the multiplication of the transfer function itself. So it is the rule number 6 is going to be a converse of it. So here we'll see the diagram and we'll come to the point. So here it should be, here it is g means it should be 1 by g. We'll check it out. So what they are doing, they are trying to move the summing point from the right side to the left side. So I'll draw the diagram here. So the a input is given, the summing, it is being given to the summing point, and it is being given to g here, and the output is obtained. The second input is given directly to summing point b. Actual output is going to be ag plus b, but here we will get something like ag plus bg. We are not supposed to get bg here, it should be b. So what is the compensation I will multiply? I will multiply a compensation, that is 1 by g, such that I am getting the output as ag plus b. So these are the 4 rules, rule number 3, 4, 5 and 6, by using which we can move the summing point and the branch point to the left or the right of the block, and we can find whether the blocks are in series or parallel. So here I have drawn a small tabulation based on the compensation and the element. Here the element is branch point and summing point, and the compensation to be given when the branch point is moved ahead of the block is 1 by g, and the branch point, the compensation that should be given when the branch point is moved before the block is g. So by using this tabulation we can find the rule number 3, 4 and 5 and 6. Rule number 7, 8, 9 are so simple because it is just playing with summing points, because summing points can accommodate 3 inputs and 1 output. So here the first one, rule number 7, is interchanging the summing point. Here we have 2 summing points here, 2 summing points, and they are asking you to interchange and check whether the output is same. So we are doing that. So the input is a, this summing point is going to be moved here, so the input here is going to be c, that is negative, and the b will be given to the second summing point, that is positive. So the output of first summing point is going to be a minus c, the output of second summing point is going to be a plus b minus c. The output remains the same. So interchanging of summing points doesn't create any problem, so we do not give any compensation. Similarly, rule number 8, here we have 3 inputs given to a same summing point, and based on the necessity we can separate it into 2. Likewise, like see what we see in the previous diagram. So a is here, the second input b is given here, and the third input c is given here. So the output remains the same, it's a plus b minus c. So there will not be any variation at all. So splitting, interchanging and splitting is not a problem. The rule number 9, we have seen splitting of summing point. Now we are going to see combining of summing point. As I said earlier, the summing point can accommodate 3 inputs, and it will have 1 output. So all the 3 inputs are given to the summing point. So what are the 3 inputs? It's a, b and c, and we have to mention the sign too. It's a plus, plus and minus, so the answer is going to be a plus b minus c. So rule number 1 and rule number 2 are the basic rules, and rule number 3, 4, 5 and 6 are the important rules by which rule number 1 and 2 is obtained. Rule number 7, 8, 9 are interchanging the summing points, splitting the summing point and combining the summing points. The last rule, we do not have a series blocks. We do not have a parallel blocks. Even though we are moving the summing points or the branch point to the left or the right, we do not get any parallel or series. The last thing we are supposed to observe here is whether we have a feedback loop. If we have a feedback loop, we are supposed to eliminate that feedback loop. Consider we have a feedback loop. I have mentioned a feedback loop here. R is the input, C is the output. It is been given through a transfer function G, and a part of output C is been taken and it is been given to a feedback element H, and it is being given to the summing point. Right? So using this diagram, we are supposed to get a simplified equation such that whenever we find such feedback loop, we can replace it by that simplified equation. So we'll solve this feedback loop. So we are supposed to find the output, no? So C. So the part of a C is given here. So C is multiplied with this feedback element. So the output of this feedback element is CH. This CH will be added with this input in this summing point. So the output of the summing point is going to be R minus CH. This R minus CH is multiplied by G to give R minus CH into G. Now this is the output. So according to the diagram, C is the output. Based on the calculations we have done, it is R minus CH into G. Our intention is to find the transfer function, which is C by R, output by input. So what we do, we just take the common terms and move to left side or right side such that we get C by R. So I'll do the same. It is C is equal to RG minus CHG. So I'll move this C term to the left. So it's C plus CHG equal to RG. I'm taking C common. So it is 1 plus GH into RG. So as I said earlier, C by R is our intention. So I'll move R to the left side and this bracket term 1 plus GH to the right side. So it is G by 1 plus GH. This is the simplified term. So when we get a transfer function like this, feedback loop, after solving it, we can replace this feedback loop by using this block, that is G by 1 plus GH. This block can be replaced, and we can replace this block by using this block. Now what we have seen is a negative feedback, because the summation here, so summing point is negative. So this is for negative feedback. So what happens when the feedback is going to be positive? So here it is positive feedback, the summation is going to be positive here. The same calculation will be done and the answer will be C by R equal to G by 1 minus GH. So with this, the reduction of block diagram has been completed. The rules of block diagram has been completed. In next videos you will see a series of block diagram problems, and we will try to use these rules and find a simplified terms. Thank you.
Thanks for watching this video. If you like this video, share it with your friends. Kindly subscribe the channel and click the bell icon for constant updates. Thank you.